Hello there, it's Jay here from Jay's Vintage Junk, and today we've got a 48K Spectrum to have a look at. Now, put it in a box here. This belongs to another YouTuber. If like me you're into your classic cars and motoring in general, you might have come across the YouTube channel Furious Driving. I was watching one of his videos, I think it was last week or the week before, and the chap's got a Sinclair C5, rather stripped out, hell of a project. Sinclair C5. It's actually going to be a really interesting project to see what he can actually do with it, because it's basically missing all its original control gear. It's missing its motors, drivers, battery, everything. So he's got a blank canvas to build something really cool. I've got a bit of an affinity for the C5 myself, because when I was a teenager, one of my friends, actually his dad, picked one up. We used to terrorise the neighbourhood around here, tearing round on this Sinclair C5. So I do like the C5s. Anyway, when I was watching the video, he mentioned that his first computer was a Spectrum, and he was quite into the Spectrums, and he'd actually bought himself one, I think from a market stall, basically as a bit of a, you know, a reminiscent of his youth. But he did mention on the video that he didn't even know whether it worked. So I sent him a message saying, well, I repair vintage computers, would you like to send it me and we can see whether it works, and I'll get it up to a functioning state for him. So that's what he's done. So we've got a box here, a 48K Spectrum, power supply, and I think he said there's a joystick interface in here as well. So what we'll do, I'll get you down on the bench here. We'll open the box up. I did open it because I weren't sure what was in it, but I haven't gone through it yet. So we'll open it up. We'll have a look, see what the condition the Spectrum's in, have a look at the power supply and everything. So I'll just get you set up on the bench now. Right, we're set up, so let's see what we've got in the box. I'll have to say he's done a really nice job unpacking this. So this is what we like to see, isn't it, when we receive a vintage computer? Plenty of bubble wrap. I'll take all this out because I can use all that when I send this back to him. Right. Oh, awesome! A couple of Furious Driving stickers there. I'll have to decide. What vehicle's worthy of having that stuck on it. There's a little one as well. I'll have to find somewhere for that. Put them out of the way. I think here we've got. Yes, I think we've got a 48K Spectrum. Oh wow! We've actually got a very clean 48K Spectrum. That is superbly clean. Just look at the faceplate on that. I don't know whether he's possibly put a replacement faceplate on it or not. I don't know, but that is immaculate. And the computer itself, I mean, just a quick cursory glance over it. Oh, this is in really nice condition. No, this is in lovely condition. There's no scratches, there's no... Whoever had this really looked after it, by the look of it. That looks in absolutely superb condition. I'll put that to one side. Let's just have a look at the next thing. I'll better have a look at the power supply, make sure the power supply is okay. Let's have a look. Right, well that's not so good. Right, so we unfortunately have some damage there to the power supply. The cable, the mains cable itself looks okay, but that will need addressing. We can't leave that like that, because that's just ready to short out at any notice. Oh, and this has been, yeah. We've obviously in the past this has had some issues with the cable. If we look, the cable is actually damaged. It's been resoldered. They haven't even put a new connector on. Actually, what they've done is they've pared down into the old connector and resoldered the wires back on. And again, like I said, we've got where the power supply, where the cable actually enters the power supply there. That is actually damaged as well. So we're going to have to do some repair work actually on the power supply itself. Let's have a look. It should have a joystick interface. He did mention which one it is, but it's just it's jumped out of my mind right now. Right, let's take a look here. Oh, right, that's for something completely. That's an early Mac laptop power supply. Yes, I'm going to have a look at while I was doing this. So I might have a look at that in a different video. That's not Sinclair Spectrum related, so we don't need to really worry about that in this video. But we do have excellent. We have a DK-Tronics joystick interface. Is that? I will have to check actually. Oh dear. Right, I'll have to double check, but I think that's the joystick interface for a ZX81, not a ZX Spectrum. Now they look very, very similar, but if you look at the edge connector there, it's a lot smaller on the ZX81. The Sinclair Spectrum, the edge connector there is actually a lot wider. I have a feeling that is a Sinclair ZX81 joystick interface, not a Sinclair Spectrum one. I will double check on that, but like I say, I'm pretty sure that's that is the case. But not to worry about, we can sort something out about for that. But wow, let's just look at this Spectrum. That is in absolutely fantastic condition. I'm actually blown away with how good a condition that Spectrum is. Look at the lettering here. It's absolutely perfect. I was wondering whether it had been recased or something, but you wouldn't have such a nasty power supply in a really nice computer. Quick check inside. One of the things you can do with the spec is you can actually get an idea whether it's an early or a late one just by looking in the back. Basically, if we look in the edge connector there, we can see a heatsink. We can see a heatsink running right across the back of the Spectrum there, which means that this is going to be either an issue 3 or a 3, possibly a 3B, unless the board's been changed in the past. I mean, it could have a board out of a Spectrum Plus in it. It could have you know, up to like a Rev 6 board in it. You never know what's happened in the past. But if this thing hasn't been messed with in the past, I think it's either going to have a Rev 3, most likely a Rev 3 board in it. It could possibly have a Rev 3B, but most of the Rev 3B boards I think tend to be found in the first of the Spectrum Plus models. But that is in super condition. I'm absolutely amazed how nice that is. So I think the first thing we're going to do is we'll open this thing up and we'll just give it a quick visual inspection inside before we go any further. I mean, I am going to be doing a full, let's get you in a little bit. I am going to be doing a full recap on this. Like I said, I want to make this computer nice and reliable for him. So he can actually, you know, he can use it, he can play some vintage games on it. We'll get the old anti-static wrist strap. Get that on. There we go. Let's just get a suitable screwdriver. There we go. Let's turn that over. It really does look like no one's ever been in this thing before. Oh, I've just noticed we've got a foot missing there. Hadn't noticed that, but I've got replacements for them. That's not an issue at all. We'll put a new foot on it before we finish with this thing. We'll open it up. I'm curious to see if anyone's worked on this thing recently, and you know, in recent years or not. There we go. That should be all of them. I don't think there's one underneath that. No, that should be it. There we go. We're in. As you know, with these you have to be super careful just to make sure that you don't damage the ribbon cable. I actually think I'm out of new membranes for these as well, so if the membrane's no good I would have to actually order one in. That's one off. That's the second one off. We can get that out of the way and out of harm's way. It's just super clean. In really nice condition. And we seem to have a very nice condition Spectrum in here. Doesn't appear to have ever been worked on before. I'll have to check out whether that's a factory mod. I don't think I've come across that before. We've got two diodes soldered in here. I'll just have to check on that. But everything else in here is looking in really nice condition. I mean, there's no rust on here. Most of the Spectrums, you know, I mean, if you work on these things yourself like I do, you know that most of these that we find now, they've spent 20 or 30 years either in an attic, in a cellar, or in an outhouse or an outbuilding somewhere. You usually see rust on the modulator there, certainly rust on, I've seen a lot with very rusty screws on the base, but certainly rust on the modulator. Look how shiny that is. So this one is in absolutely super condition. It is a Refurb Pt1, so it's a that's again slightly more unusual to find in a rubber key Spectrum. The 3B more often than not you find in the plastic key, the Spectrum Plus. But I am guessing it is 100% original to this computer. And it is in, like I said, really nice condition. We'll get the board actually out of the case. Then we can put the case to one. Need something slightly different for that one. Then we can actually put the case to one side. I think it should just be the one screw. So it wouldn't be like Also, Clive to waste money on things like screws. That's out of harm's way as well. But no, that is in absolutely beautiful condition. Oops. Let's give it a quick flick over. Yeah, that is really nice. It does look like it may have had the CPU swapped at some point. I just noticed some flux residue on all these pins here. If you look, and the solder doesn't look quite, I mean, it doesn't look bad, but it doesn't look quite as uniform as on the rest of the board. So I have a feeling at some point in its past it has actually had a new Z80 fitted. I can't see any other work has been done to it. Doesn't appear to have had any of the RAM ever swapped out. We've got Texas Instruments RAM for the upper 32K, and we've got the STC 4116s for our lower 16K. So yeah, super nice condition. Right, what I'm going to do with it, we're not just going to plug this in and see if it just works. We're going to actually go through this properly. What I'm going to do is basically I'm going to just run the Esr Tester over the capacitors. Just make sure there's nothing really bad on there before we actually attempt to first power this thing up. Obviously what we're also going to do is we're going to have to do the composite video mod on it, so we can get it to display on a modern display. We will be doing that anyway, so this is as good a time as any to do it. But what we really don't want to do is just comp mod it, put power up it and see what happens. Like I said, we could have one of these capacitors, especially in the DC to DC converter circuit round here. We could have a bad transistor. We could have a bad capacitor, which will basically stop one of the voltage rails going. Best thing to do first, really, is just to test at least the capacitors in the DC to DC circuit and make sure that there's nothing terribly wrong with them. The easiest way to do that in circuit is with Esr Tester, which is exactly what we're going to do. So we've got two 22 UF there, we've got the one UF, got another one UF, I think that one should be another 22 if I'm correct. Yes, that's another 22 UF. I think that's a 1 UF there. Yes, that's a 1 UF. I think that's a 1 UF there. Got another 22 over there. And we've got 22 there. I think that one might have been swapped out actually. Oh no, no, it's the same. We've got another 22 there and a couple of hundreds down there. And one of those hundreds I can already see has been running hot. Let me zoom you in and you can see. Oops. If we look there, can you see how the casing started to split on it? That's pretty telltale that that capacitor's been running rather warm. Obviously those two there are 100 UF. Let's get you out a bit and get the Esr tester going. Okay, there we go. That's compensated, that's zeroed out. Let's try the first of these 22 UFs up here. Right, we've got 20, it's coming up as 0.44 ohm. And we'll just check 22 UF, 25 volt, that's absolutely fine. We'll just check the next one. Now that one's a little bit higher at an ohm. It's Let's have a look along on the chart. It's a what voltage rating are these? I think they're 25 volts. So yeah, I mean it's still in it is actually still in spec. Now that's showing 3 ohms. That's a 1 UF. So with 1 UF, 25 volts. Again, it's showing 5 as your maximum. So it is still in spec. But again, with this being a 3B board, you don't tend to find as many issues with these 3B boards as you do like the issue 1 and the issue 2 boards. That's a 22 1.63 ohms. A 1 here if we can get to it. Let's see if we can. Now we've got a 1 UF there that's actually showing as open. That one there is actually showing as open. It's not showing anything on it at all. So we definitely do have a few capacitor issues by the look of it. We've got a 22 here. Let's try that. Let's test that 22. And get into the connection on this side a little bit high because I have to go underneath. That's 2.1 ohms. So again, they're not exactly great, but apart from them 1 ohm ones, they're not exactly great, but they're not exactly completely dead. We will have to swap out that one that's showing open circuit though. Right, let's have a look at these two 100s here, because like I said, that one is not looking healthy. Let's make sure we find out which way. So that's the ground side is this way. Ah, one's what that way, one's that way. So let's have a quick look. So that's ground. That we'll try that top one. That's the one that looks like it's got some heat damage to it. And actually, ESR wise, it's not looking bad. 0.4 of an ohm. It's right on the top limit at 0.4 of an ohm, so it's not exactly healthy. Let us do. This one is in the opposite way around. And that one is 0.2 of an ohm, so that one's obviously in slightly better condition. Let's just try this 22 up here. I mean, those are the ones that I was more concerned about, is the ones around the DC to DC converter. Again, that's okay. Again, that one's okay. Little bit on the high side, but it's not terrible. And the same with that one there. So essentially, it looks like we've got a couple of capacitors in the DC to DC circuit there, which are. I would not be happy just switching this computer on, because if the DC to DC converter doesn't start up correctly, what you risk doing is damaging the 4116 RAM down here. So what I think we're going to do is we are actually going to go in and we're going to recap. In fact, it's daft. It's daft once if we get in the if we're getting the desoldering station all warmed up and everything, we might as well go through and just recap. There's only, you know, there's not many capacitors on one of these. We may as well go through and actually replace those before we actually attempt to apply power to the computer. Just for peace of mind, basically, because I know it does look like we've got an iffy 1UF capacitor, and it is in the DC to DC converter around there. It's not saying that we don't have a bad transistor, but which would also probably cause an issue in the DC to DC converter. But it's less of a chance. Like I said, that's a risk I'm willing to take, as where when I know that there's some suspect capacitors, and I know how simple it is for us to just swap them out before we go any further. We may as well swap the capacitors out. We may as well swap the capacitors out, and then, like I said, we'll do the composite mod on it, and we'll actually see whether the computer at that point is actually going to work. It's actually going to function. So we'll get the desoldering station switched on and warming up. In hindsight, I should have really put that on earlier. Right, now where have I put my glasses? There's my glasses. I still can't get over how absolutely amazingly clean this thing is. I've spotted another issue as well. We've actually got a dry joint on the 7805 there. That looks like that may have been swapped out as well at some point. And if you, let me see if I can get you down. Oops, other way. Down we go, down we go. Can you see how that's been bent over to one side like that? I think that's been done where whoever tightened the screw up there wasn't holding the voltage reg, and it's actually allowed it to twist as it's been tightened up. Now the problem is, when they solder that in, they've not really let the iron heat up fully, and we've not got full penetration on all three of those connections there. If we actually spin it over, let's see if we can get this in shot. I don't know if this is going to come out, but that connection there is actually dry jointed. We've actually got a dry joint on that connection there, which, as we know, is not going to be good for the computer. In fact, I think what I'm going to do, I'm going to resolder that before we go any further, because that could potentially stop the computer from firing up. It's another. I'll probably put a brand new 7805 on this, considering I've got boxes and boxes and boxes of the things. And like I say, I want the computer to be reliable for him for as long as possible. But for now, I think I'm just going to reflow all three connections there, because it does look like whoever works on this last swapped that out and then managed to fracture the solder joint there when they was refitting it. Right. In fact, what I'm going to do, I am just going to very, very quickly pause the video, and I'm just going to quickly look up this little mod here, because it's a while since I worked on one of these 48K Spectrums, and that is not a mod that I actually remember off the top of my head. I just want to quickly look that up before we go any further, so back in a sec. Okay, well, I'm back, and I've done a little bit of reading up, and it does actually appear that this I'll get you down onto it so you can see what we're looking at. Oops, down we go. There we are. That's better. It does actually appear that this here is actually a service mod. Apparently, I had a look up. It's it was done on the issue 3 and the 3B boards to improve the reliability of the DC to DC converter. In fact, what it does say is that this mod is actually basically integrated into the later boards, so the issue 4 and later boards actually have this mod as part of the main PCB. But it was done, like I said, it was done as a service mod on the issue 3 and 4 motherboards. So knowing that, and now no, it's not some horrendous bodge or anything. It is something that was done by a service centre. Like I said, it was done as an improved mod by Sinclair to improve the reliability of these boards. So I'm quite happy with that. So with that in mind, I think what we'll do the recap, because we do, like I said, when we tested with the ESI meter, one of these, I think it was that one, was actually coming out as very high ESR or open circuit. It was coming out greater than 25 ohms, so we know there's, I think we've definitely got an issue with that one there. Everything else, actually, I mean, some of these are getting tired, but if it weren't for that one there, it wouldn't actually, I wouldn't actually be too worried about powering the computer up. With that capacitor there being as iffy as it is, I think I'll go ahead, I'll recap the board, we'll do the comp mod on it, and then we'll see if it actually fires up. We'll actually see what it's doing at that point. We can take some voltage measurements, make sure everything's happy really. So I've got a bag of replacement capacitors here. And get my caps out. Right, there we go. They're ready. Let's get you. Oops. Let's get you up a little bit further so you can see. Let's try zooming you out a little bit as well. There we go. That's better, isn't it? You can actually see what I'm doing now. Right, we have got first two capacitors are a pair of 22 UF. We'll just look here, and they're both in the same orientation, so the negatives are both to this side here, positives on that side. Obviously, as you know, these are electrolytic capacitors and they can only go in one way round. You don't want to make a mistake and put these in the wrong way round. Let's make sure we find some 22s. Those are ones. 4.6. I mean, one of the great things is you actually only need 4 values of capacity to replace the electrolytic capacitors on one of these 22s. Here we go. So we'll get those out. In fact, just for what we'll do, we'll pop them two out there, and then we'll just quickly measure them out of circuit and compare them to the brand new ones. In fact, we're actually the original capacitors are rated at 16 volts. My replacements are actually rated at 25 volts. They're ever so slightly bigger, but it won't cause any problems at all. That, and as you know, you've no problem going up with the voltage rating. You just don't really want to go down on it. I mean, obviously you can't go silly. I wouldn't be sticking 22 UF 400 volt capacitors because of obviously the physical size, but a little size up like that. Like I say, it's just from 16 volts to 25 volts is absolutely fine. Right, let's start by taking these two first capacitors out. Now, it's really up to how you do this. I'm going to be using my my desoldering gun. You can quite easily get away doing this using a manual solder sucker. I have this, so obviously I'm going to use it, but this is something you can quite easily do just with a manual desolder pump and a soldering iron. we go. That should be the first two capacitors loose. Turn them back over. Just give them a little rock, just make sure that they are actually free. Yeah, those are free, look. And we can get those off the board. Let's just try and find something we can lift those up with. There we go. Just a little bit of the, as you can see they are perfectly loose, but there is just a little bit of solder just holding them. Yeah, let's try with these. There we go. And we can just lift those out of the board. Those are the replacements for those two there. Just want to bend the legs in. I like to face them so you can actually see what the value is. It just makes life easier for future repairs, really, more than anything else. And obviously we want to make sure that they're orientated in the right way. That one in there like that. And just bend the legs roughly in. Give that a little bit of a twist so we can see the value a little bit better. Push him home. That's the first two. Just make sure that they're nice and flat on the board before we solder them. That's the first two new ones in position there. 22 UF at 25 volts. Spin the board over and we can solder those in place. Just need to snip those legs off. Where have my snips gone? Snip seems to have disappeared. Yes, my snip seems to have disappeared out of my toolbox here. It's always the flaming way when you're making a video. Just bear with me a second, folks. Found them. Right, we can carry on with this. I'll get those snipped off. That's the first two new capacitors there. I won't go through doing every single one of these capacitors on camera because it'll get a little bit boring. But I'll just do. I'll do the ones around here, around the DC to DC converter, and I'll probably just change those two on camera. And there's nothing else here really, I don't think, which is actually going to cause a problem which could cause damage to the computer. Like I said, the most critical part is here. But I'm not sure whether that's not used in the DC to DC converter, so I will swap that one out. But our next capacitor is a 1UF, which is that capacitor there. Now let's have a quick look underneath. See, one of your trickiest things is actually finding which pad is relevant to which component. I mean, we've all done it, haven't we? We have in the past actually desoldered the wrong part. I know I'm guilty of doing that in the past. That should be the right, I think we've got the right one there. It was out. Sometimes what happens is the leg actually gets bent over a little bit, depending on how it's being soldered. I mean, a lot of these would have been hand soldered originally. I know a lot of the later ones will have been wave soldered, but I'm pretty sure that a lot of the very earlier, that's not good English, is it? The earlier Spectrum boards were possibly hand soldered. And the leg is bent over on this little bit, and it's proving quite difficult to desolder. I think that's got us. Let's have a look now. What I might do is just check, see if I can desolder the other side at the same time. Which should be that one there. Just basically, if you desolder both sides, and it's free, you should be able to just gently rock. There we go. So that's free on that side there now. Just gently waddle it. You're not trying to waddle it off the board or anything, you're just trying to make sure that all the solder is off. And I said, they seem to have bent the legs over on this one as they put it in, which is making it a little tricky to get out of the board. There we go. So once you've got one side out, it makes getting the other side out a lot easier. There we go, that's out now. So 1UF, and I've got a negative on this side, positive on that side, and that actually, I believe that one is part of the DC to DC modification that's being done, because the actual designation there is D10. I do know that you replace on the modification, there is various components that you actually swap out. Not as in, you know, for a different value, you know, you swap out like a resistor for a diode, and I think a diode for a capacitor, and quite, you know, there's it isn't just a case of adding them extra diodes and cutting that diode out there to do the upgrade for the DC to DC. There's a little bit more involved than that. So I've got quite a few 48K main boards, and I've got a couple more issue 3B boards and issue 3 boards, and I can't say I've ever actually seen that mod be implemented on one. That's the first time I've ever actually seen that modification implemented. So I presume, I mean, Sinclair must have deemed it a worthwhile thing to do, and I'm guessing, because it does look like the CPU's been swapped on this particular board. So I'm wondering whether at the same time as the this went into a Sinclair approved service centre, or it even went back to Sinclair themselves, probably a service centre. And as well as obviously replacing the faulty CPU, at the same time they did that upgrade to the DC to DC converter circuit. Right, so that's 3 changed. We've got this one here, which is part of the mod again. It's actually connected to those 2 diodes, and then we have another 1 UF there, which is going to be quite tricky to get out because of the mod actually. I think on the mod they've actually brought that capacitor through one of the vias here to connect. So that's connecting up to the ground plane. Yes, that's going to ground. And they've actually gone straight through one of the vias on the board. So that's going to be possibly quite tricky to remove. Let's see if we can get... So we can get the leg to lift up now. There we go. There we are. We could do with it getting it to lift up, and then we can get the rest of the solder from around it. Right, we've got it to lift up enough that I think I can get it with some pliers. There we go, that's lifted up, where I should be able to get the desoldering station back on that. There we are, that's free. Just flip the board back over, and we should be able to get that capacitor out now. Oh, it's not actually the it's not actually the ground that side, that's the +5 volts I think. Yeah, because that side going to the diodes is the negative of that capacitor. There we go, that's out of the board. And now I need to disconnect it from the junction of those 2 diodes there. So hopefully it'll pull free. Whoever did this, I think, was probably quite an old school engineer, because this has been done. They've actually bent the 2 diodes together and created a nice mechanical joint before they've actually soldered it. I was hoping I'd be able to just whittle that capacitor lead out of there, but what I might have to do is just cut it off and add the new one on top. It might create less damage doing it that way. What I don't want to do is overheat them diodes, because you don't want to get diodes too hot, especially not that close to the end, because you can damage them with the heat just from the iron. There we go, that's just clicked off. And that's another 22. Yeah, that's another 22 UF. We've got a replacement for that here. If we want to go in that way. In fact, it might actually be easier to change that next capacitor there before we put that capacitor back in. Or else it's going to be easy to take that one off, then instigate that one, because it means I can actually get to that via without trying to force it around the bottom of it. So let's pop that capacitor off there. We'll then reinstigate that one, and then we'll try and get that one back in. That one's going to, those two are going to be a little bit tricky, unless what I could do actually, because that's a bit longer on that side, this will make life a lot easier for us. If I lift the diodes there, I can just bend the diodes up and out of the way like that, just while I access these components around here. Right, let's take this next capacitor off. This is a 1 UF. Okay, that's free. We can take him out of the board. Let's get another 1 UF. That one goes in there like that. And this one we will put in, because it makes life easier to get that in that hole there. So this board was never designed to have these capacitor, well, this capacitor and that capacitor actually in place. These were part of the modification. So we need to get them in there as neat as we can, really. That's going to work quite nicely. We'll bend that back down there like that, and we'll solder the back, and then we'll reconnect. In fact, we won't. We'll solder that side there. We'll flip it back over, we'll change that next capacitor, then we'll make that end good there. One. That's the one that goes to the via. There we go. Cut those off now. And flip the board back over. because that one, like I said, is going to have to connect to that position. That, let me get you in so you can see. As you can see, that capacitor that's currently floating will have to reconnect up to those two diodes there, which we just temporarily made free. Let me just pull that out of the way again. We temporarily made those free. In fact, what I might just do, yeah, I'm just going to reheat that Oops. I'm just going to reheat the connection on that side of that capacitor and see if it'll go down a little bit. Because I'm a little bit concerned about that joint being a little bit close. There we are, that's better. We'll have to trim that back off again after. That's alright now. So we'll do that next capacitor there, and then we'll put all this back together how it should be. And we should be quite happy with that then. Snip that extra bit of leg off there. That was just the excess where we pulled that one through. And our next capacitor, let's just double check. It's that one nearest the Molex there, so we go on there, take that end out, take that end out. I'm not sure if these are hand soldered or wave soldered. The wave soldered, some poor buggers had to go around and fit all these, unless they wave solder the ICs and then someone goes and puts the passive components on manually. That could be, I mean, we're talking quite early mass production of PCBs when this was made. Right, so we've got a 4 that's the 4.7, only one 4.7 on these. One of them. And that goes in there like that. Get that nice and flat down on the board. Spin that back over. We can solder that into position. There we go. So that's all those capacitors there changed. All we need to do is reinstate the modification here. So what we need to do, we'll put that down on that trace where it was originally soldered to. We can put that straight back where it was. Add a little bit of fresh solder to that. There we go. So you got to be as quick as you can. You don't want to heat up around those silicon diodes if you can help it, because prolonged heat on them will damage them. We'll bring that. Let's see if we can just bend the new capacitor leg around the junction of those two diodes like that. We'll snip off. So we've basically done what the previous repairer had done and created a good mechanical joint between the capacitor and the two diodes there, and then we'll just solder it to make it a good electrical joint. So we go in, so we'll be as quick as we can with this joint. That should do. So that's all those capacitors changed. All we need to do now, we'll swap that one out, we'll swap those two out, and then we can give it a try. The other ones, like I say, I'm not too concerned about, because none of those I should think would actually stop it from really working. They certainly won't stop the DC to DC converter to working, and that's what I'm most concerned about when I'm first firing up one of these all Spectrums, especially one that, you know, I mean, the chap did say he hasn't tried it himself, so we don't know when the last time this thing actually had power given to it. Go, that should do. That one's free. Out you come. There we go. That is another one UF. One UFs. Sure he's nicely down on the board. That one. That one. Okay. So all we've got to do really is swap those two out. So like I said, I'm not happy with trying to power it up with that one. That one looks like it's been running very hot. Just make sure they are both in opposite ways as well, so we've got positive on the top ones to this side and positive is on that side on the bottom one. Let's get these out and we'll that one dropped straight off the board. Yeah. You know that capacitor's not happy. Can you see how it's actually completely split its jacket? We'll try that on the tester after, but that does not look happy at all. That one, see, that one looks alright. I mean, I'm sure it's, well, they're all tired, they're all, you know, getting on for 40 years old now. I mean, when did this board, this is an 83 board, so they're what, 39 years old now. So they're certainly getting a little bit tired. Right, those are hundreds, so we want a couple of hundreds. Where are my hundreds? There's the hundreds. I've only got 4 packets, so there's only 4 values used, but why can you never find the one you want? So there's 200 UF. Just get them farmed up. That one goes in that way around. Like that. Push him down onto the board. And this one goes in the other way around. Like that. And again, just make sure it's nicely flat against the board. And we can solder those 2 in place. Okay. All snipped off. There we are. That's the capacitors there changed so far. So that makes me quite happy to actually now power this board up, because there's no capacitors there that I consider, if they were bad, if these 3 are bad, that they are not actually going to cause a major issue that's actually going to stop the DC to DC converter from working, which could, like I said, potentially damage the lower bank of memory. Next thing we need to do is we'll do the composite mod on it, so we can actually get a image on a modern screen out of it. So with that in mind, this is ever so simple. In fact, let me get you zoomed in. Everyone I'm sure that's watching this has seen or done a composite mod on a Spectrum. But basically what we want to do, we take the top of the modulator box off. I want to do this in a completely non-destructive way. Basically, I want to be able to do this in a way that in the future, for any reason someone wanted to revert it back to RF use, it will be dead easy for them to do. Basically what we need to do is we just need to link this box out, because the actual ULA produces and the video circuitry around here actually produces a composite signal. It's just that this modulator then takes that composite signal and converts it into an RF signal for use on the older televisions that just had an RF input. So all we really want to do is bypass it. First thing I'm going to do is I'm actually going to disconnect its power, because there's absolutely no point in having it running on there just doing nothing. All you're doing is just pulling extra power that you don't need to. So we take that back wire there, and we've desoldered the end of it. We can pull that out like that, and all we want to do with that is the 5-volt input to the modulator. We're just going to, in fact what I'll do is I'm going to bend it up and then just bend it back round like that, so when I put the lid on, the lid will just trap it in place. If ever you wanted to revert the computer back to as it was, literally all you would have to do is pull that back out and put it back down through that little hole there and resolder it into place, and that actually power the modulator back up. The next thing we need to do is there's a resistor here connected to the back of the phono jack here. We need to disconnect that from inside. So again, if we take a soldering iron, and sometimes I've seen it actually done properly and actually bent in, and most times it's just literally just laid on the top and soldered. Let's just heat it up and just hopefully, yeah, in this case it's like in most you find it's just laid on the top and soldered, so it's literally just heated it up and just bent it out of the way so it no longer connects with the center point on the modulator. Oh, sorry, on the phono output there. And I've actually forgotten to do something. This wire here, you know how we desoldered that connection there, which was the 5 volts into the modulator. What I'm going to do, because I'm doing this in a totally non-destructive way so it can be reverted, what I've done in the past is actually desolder that from the bottom of the modulator, pull it up and solder it straight on there. But you know, then if you wanted to take it, revert it back, you would actually end up having to take the modulator off to solder the wire back. So what I'm going to do, I'm going to disconnect it, and I've done exactly what I did before, and I've bent it back up round, and basically when I put the lid back on there, that'll just hold it in place so it can't short against anything. It's perfectly safe like that. What we need to do now is just run a wire from there into the modulator and connect it to that centre point there. I've got some hookup wire lying around here, I think, somewhere. I've got some bits in here. Have we got any black? It'd be nice if I had a piece of black. It'd be even nicer if I had a piece of yellow, actually. Oh, there's some yellow there. That'd do nicely. So I've got a little piece of yellow. Yellow obviously being the colour for composite. What we want to do, where that second wire we took out from, oops, let me get you on in the shot, where that second wire from the modulator, we disconnected it, we solder this yellow wire to that point. Oops. Hold that in position. There we go. A little bit more solder to that. Trim the excess off. Like that. Right. If we feed that on the side of the sorry, you can't see again, can you? There we go. If you notice on the side of the modulator there's two actual little apertures. We can use the one that isn't being used to feed that wire inside the modulator. Let's get hold of it with that, if I can. There we go. Pull that up. Get you up so you can see what I'm doing a bit. There we go. And we'll pull that in. And basically all we want to do is solder that then to the centre pin of the phono connector. So we'll cut off the excess that we don't need. Right there. Strip the end bit of wire. Like that. Strip a bit more off than that. There we go. We don't need very much showing. We'll tin that up and then we'll solder it to the inside of there. Hopefully you can see what I'm doing. So we just want to tin the end of that wire and then literally solder it to the centre point on the phono connector there. And that's basically the AV mod done. It's about one of the simplest computers to AV mod the 48K ZX Spectrum. There we go, tin that wire up, and then all we need to do is solder that wire, bend it down, and just solder it onto the centre there. Got that in the right position. There we go. And it's as simple as that. Let me get you there. Let's see if I can zoom you in a little bit. Hopefully you can see that there. We've got the little wire soldered that comes through the side of the case in there and just solders to the centre pin of the RCA, sorry, not the RCA, the phono connector there. If you look on the, oops, let me get that in shot. And then if you have a look there, you can see the wire coming out and connecting where the original input to the modulator went in. And like I said, we've got the original modulator input just folded over the top, and the 5 volts that would have powered the modulator folded over the top. So if you wanted to revert this back to as it was absolutely original, all you'd have to do is remove that wire that I added there, reconnect that into its position, reconnect that wire to the 5 volts position, and reconnect that resistor back onto the end of the phono connector in there, and it would be exactly as it was when we started. And but you would then be limited to just using the old-fashioned tellers that have an RF input. Right, basically as it is now, I'll get you zoomed out a little bit, we are actually in a position where we can actually basically test and see if this thing is actually going to work. What I will do, I will get you down a little bit and I'll tilt you up so you can have a look at the test screen. I think I'll have to, you can see that alright with my lights on, can't you? We'll connect up the spectrum and we'll see what we get, if we get anything at all on screen at this point. So I've got my spectrum connected up. Connect that up to the monitor. And now power wise, because the original power supply isn't really in a state for we can actually test it with, I'll use one of my test power supplies. This is just a 9-volt DC supply that it's got the correct polarity, because as you know, the Spectrum has, it's like the Sega Mega Drive, it has center negative, so it's center of the cable there is negative and the outer sleeve there is actually your positive. But that's how this transformer is wired, so we can use this for testing. Hopefully I've got enough room on here that I can actually plug it in. There we go. Right, so we've got power up. Let's switch the monitor on. I'll put the power into the back of the Spectrum, and we will switch on and see if we get anything on screen. And we get nothing. Quickly switch off. Well, that was an anticlimax, wasn't it? We didn't even get anything at all on screen. So we seem to have a dead, completely dead board. So I think it's going to be time to dig out the tester and let's see what's going on. I'll get you back down onto the board. and we'll do some voltage checks and see what's going on. Okay, scratch that. I was an idiot. I just realised as I went to get the meter, the little SCART to photo adapter I've got there wasn't actually pushed into the wall properly. So if we quickly go up onto the screen now and I switch on. There we go. Sinclair Research Limited. No, I will check that it's my screen. That appears a tiny little bit dark to me, but look how crisp this is. This is lovely. It's actually giving a really nice. It just appears a tiny little bit greyish to what I would expect. And unfortunately, on the three and later boards, it's not as easy to actually adjust that as it is on the issue, like the issue 1 and the issue 2 boards, because you actually had trimmers on the board that you could tweak the actual screen with. It's all pretty much preset on the 3 and later boards. I'll actually have a look at a couple of my other issue 3 boards and see quite how grey they look, but that does look a tiny. I might try it on a couple of different screens as well, see if it makes any difference. But so far so good. We are actually getting the main screen up. I'll quickly just connect the keyboard up, and we'll see how much further we can go. Where did I put the keyboard? Because I put the keyboard out of harm's way. There it is. We don't want to scratch up that keyboard. As I said, I've not seen a keyboard as nice as this one for forever, really. Apart from like the reissues and the ones that have been redone. We'll connect it back up and we'll just see that all keys work. Well, we'll do that in the next video. Actually check through the keys properly, fully. But let's just at least see if we can perhaps type a basic program or something on it. There we are, we're in. And hopefully that the membrane's actually going to be okay in it. Let's switch on. There we go. We'll get up onto the screen. Well, it does at least seem to be I haven't used a 48K in ages. No, wrong. Then we want symbol shift. Oh, right. I don't think we've got a working symbol shift, because I can't get my little quotation marks up. Cap shift works, but I don't think symbol shift is working. Because I should be able to press symbol shift now and press the P, which has got the print and the quotation marks, and actually get the quotation marks up. I was going to just do a quick hello world, but I think we have an issue with the keyboard. Yeah, it looks like we've got a let me just reset that. And also let's we'll switch it off, switch on. That seems very quick. That seems incredibly quick, the border block there. So I'm wondering whether this thing is only actually running for 16K. It could be that we've also got a RAM issue with the second 32K of RAM in this thing, because that there, I'll just do it again. If you saw how quick the screen come on then and then went off, that's more what I'd expect from a 16K Spectrum, not a 48K Spectrum. So I have a feeling that we've only got the first 16K of RAM actually working on this computer. So we've definitely got some more work to do on it. I know it's nice that we've actually got... This is the computer equivalent of First Light. If you watch my Pi TV I was working on, and we will be going back to that TV. This is basically the computer equivalent of First Light. We've not got it working properly yet. We do still have some issues. I'll just quickly, before we finish this video, I'll just quickly try reseating the... Well, I think that's... Yeah. That's literally... I'll just get you down. And I was not being rough at all. But unfortunately, that just broke straight off. That one on that side actually isn't in bad condition. But that one, that just snapped clean off there. I said, unfortunately, I think I'm actually out of new membranes, so I'm going to have to order one. They are easily available, fortunately, and they're not too expensive. So I will have to order a replacement keyboard membrane. I mean, I've got ones we can use for testing, so that's not a problem. So we can carry on with it, and I'll order a new membrane for it tomorrow, and that can be on its way. And like I said, we can carry on with testing because I can just use one of my other test keyboards for that. In fact, I've got one that I'll show you, which is really nice for working when you're actually diagnosing problems. Rather cool little keyboard that I've got for these things. That's a bit of a shame, but so I was not being rough with that at all. It's literally this is what happens with these old membranes, unfortunately. The plastic just gets so brittle with age, and yeah, as you can see, it's even left it in there, but it's literally just snapped off. I mean, the plastics, yeah, this plastic's just had it. I said it's getting on for 40 years, all this plastic now. I'm sure it was only ever really intended to last probably about... I think they say that they have a mind for consumer electronics of a lifespan of about 10 years. So... I mean, this thing's what? This is an 83, this is an issue 3B, it's from 1983. We're in 2021 now, so you're 39 years old. The plastic does, unfortunately, get to that point. Anyway, it's not the end of the world. It's such a beautiful... The only thing is, I'm going to have a nightmare getting that off without damaging it. There are... tricks and tips to it. We'll use a little bit of hot air, warm it up, very gently ease that off, get the new membrane underneath there and reseal it all. Like, it's not the end of the world. It's just what a shame at this point that I'm going to have to actually take that front cover off that keyboard to replace that membrane. Anyway, I'm going to leave it there for now. I don't think I'll bother having to subject you for me to change them 3 caps. So I'll swap those last 3 capacitors off camera, and in the next video I think what we'll do is we'll go over the rest of the things we need to go over actually on this board. There's some clean-up works needed on it. I've noticed that the edge connector on the back here is horrifically tarnished. That's all going to need cleaning up. There's a couple of heat sinks I'm going to put on here. Well, obviously we'll just check in, once I've done them last caps, we'll check all the voltages. I can't see any reason at all that the voltages are going to be off though with the work that we've done already. but we will check all the voltages. We'll heat sink up the ULA. That could really do with a heatsink on it, and it's not easy at all to do in these because you've got so little room to actually put something in there. But I've got an idea what we can do, which I've done on other Spectrums, just to help dissipate a little bit of heat from the ULA, especially with this being, like I said, the 3 and the 3B. This ULA is known as one of the least reliable of the Frontier ULAs that we used in the Spectrum. So we will definitely see if we can prolong the life of that. Like I said, it is definitely working at the moment, or at least it looks to be definitely working at the moment. Right, I'm going to leave it there for now. Like I said, in the next video we'll do some final work on this board. I'll tell you what we can do in the final video, in the next video as well. We will sort the power supply out, because obviously I can't send it back with a power supply that's got tape around both ends of the low voltage side of it, so that's going to need addressing. We'll do a full test on it, could do with putting a plug on it and what have you, and then we will get back to sorting this computer out. Hopefully we'll have a new membrane by then, and we can put a new membrane in the keyboard and get all this thing buttoned up and back off to the chap so he can play himself some Spectrum games again. Anyway, I'm going to leave it there for now. I hope you enjoyed this little video, so thanks for watching and goodbye.